All right, so I've never done this before, but we are going to do our notes with a video. All right, so last time we talked about how we simplify radicals and how we multiply radicals. So if we had an example like this, the square root of 325. All right, square root of 325. We had to find numbers that went into 325, and those numbers came from the perfect squares list. All right, get out your notes from last time if you don't remember what they are, but 25 is in that list and 25 goes into this number. So I break it up and I would get square root 25 and square root 13 because 13 times 25 gets me 325. All right, the square root of 25, because it's a perfect square, it becomes a normal number. It no longer has a radical. If I put the square root of 25 into my calculator, I get 5, and my final answer would be 5 square root 13. All right, also last time we learned how to multiply our radicals. So we had something like 2 square root 6 times 3 square root 11. All right, when we had something like this, we multiplied the two numbers on the outside, and that gave us 6. And then we multiplied the two numbers on the inside, and 6 times 11 gets me 66, and I put that inside the radical. All right, I would check and see if this would simplify, and this one doesn't, so then that's my final answer. All right, that's what you did last time. You have two concepts today, all right? Your first concept is to add and subtract radical expressions, all right? Now, when I'm adding and subtracting radical expressions, I'm looking to see if the numbers underneath the radical are the same. This one has 3 under all the radicals. So that means I can just add the numbers in front, add and subtract. All right, 4 plus 6 is 10, 10 minus 5 is 5, and my final answer would be 5 root 3. Okay, now, it's awesome when they're all the same number, but sometimes they're not. So this one and this one can be combined, and this one and this one can be combined, all right? So I get 3 plus 6 is 9 root 7, and 12 minus 8 is going to get me a 4 root 5. All right, I cannot combine these two radicals anymore, so this whole expression is my answer. Now, example C is a little bit more tricky. None of them are the same. That means you have to simplify them so they have the same number in the radical. All right, so when we do this, we are going to solve them. We are going to simplify them like we did up here. All right, so I'm looking at 12. I know from my perfect square list that 4 goes into 12. So I'm going to have 4 from the outside. I'm going to break it up into two radicals. I'm going to have 4 in one of them and 3 in the other. Okay, then I'm going to do the same thing for square root 48. What two numbers go into 48? We get square root 16 and square root 3. All right. And the last one, when we're doing 24, we're going to get 4 and 6. Square root 4 and square root 6. When I go to simplify these, this square root 4, it becomes just a 2. Square root 16 becomes 4, and square root 4 becomes 2. So now I'm knowing that I have to multiply 4 times 2 to get 8. I got my root 3 right there. 6 times 4 is going to get me negative 24. I got square root 3. And this last one, I'm going to take 5 times 2, and I get 10. And this one's going to have a square root 6. Now, I can combine this one and this one because they both have a root 3. 8 minus 24 is going to get me negative 16 root 3. And this term can't combine, so I just have to add that plus 10 root 6 at the very end. All right, so that's your very first concept. You got to be able to add and subtract radical expressions. Now, for this second concept, all right, you have to be able to solve radical expressions. This is very similar to what we did last chapter in the way that the square root and the square undo each other. Okay, watch what happens. This one right here. I am going to subtract 7 on both sides. Those cancel out. And I get the square root of x plus 1 equal to 3. Now, anytime you get it to this spot where you just have a square root on one side and a number on the other, you have to ask yourself, is this positive? If it's positive, you can keep going forward on the problem. If it's negative, you stop right there and it's no solution because a square root will never equal a negative number. Remember our no solution from last chapter? Okay, so it's positive. I'm going to keep going. I'm going to erase this question mark. Okay? And now I'm trying to get the x right here out of the square root. So the only thing that undoes the square root is the square, all right? So the square and the square root cancel out. And I get left with my x plus 1. X plus 1 equals, well, 3 squared is 9. All right? And I'm still solving for x, so I'm going to subtract 1 on both sides. And I get x equals 8. All right, this is my solution. Now, I don't know if you noticed, but I said you must check today. Up to this point, checking was just a formality and just to know if we did it right. But today is different, all right? And we're going to notice that when we get down here to this last example. Okay, so what I'm going to do is I'm going to plug 8 in everywhere I see an x. So I'm going to put an 8 plus 1 under the square root plus 7 equals 10. All right, I know that 8 plus 1 is 9, so I have the square root of 9 plus 7 equals 10. And the square root of 9 is 3. 3 plus 7 equals 10. Now, I don't want you to show me the final answer. I want you to show me the step before because I know 3 plus 7 equals 10, and I can do that math in my head. Give me a little check and show me that you showed both sides are equal. All right, example B. Over here, I'm going to add 2 to both sides. These cancel out, and I get 3 square root x equals 6. I divide both sides by 3. I'm trying to get that x by itself. These 3's will cancel out, and I get the square root of x equals 2. Ask yourself, is this a positive solution? Good, it's positive. I square both sides, and I keep going. All right, I get x equals 2. All right, I box my answer, and then I go to check it, all right? I have negative 2 plus 3 square root 2. Oh, right here, guys. 2 squared is 4. My bad. Equals 4. All right, so I get negative 2 plus 3 times the square root of 4, which is